All right, this is 6.6 for algebra, solving absolute value inequalities. Yesterday's lesson you solved absolute value equations. We're just adding in the inequalities today, which is, these things, which you've been working with already. So take a few minutes, pause the video, try the warm-up, and then I'll come back to you. All right, ladies and gentlemen, so here you go. If you did this one here, you're finding out what x could be to make this a true statement. So you have to set it equal to positive 4 and negative 4, and you'd get 10, you could plug in there, or 2. And so that's why I wrote it like this. Remember, don't write it as an ordered pair. And then down here, deviation is simply talking about how far I can go one way or another and have an acceptable frame. So here it says I can deviate 0.25 of an inch. So I could go between these two. This would be the maximum and the minimum for the width, and the minimum and the maximum for the length. All right, today we're just adding in inequalities. It's not really that much different from yesterday. Just got to add a couple steps. So here's what I want you to remember. I use a little saying. It's called Gore land. When I'm working with absolute value inequalities, if you have a greater, or we could say greater, you're going to have an OR graph for an answer. If we have a less than, or you could say less and, you're going to have an AND graph. So if you kind of keep that in mind when you're solving these, your answer, if this is a less than, you're going to have an AND graph, which means your graph's going to come together. If it's a greater, you're going to have an OR graph where your graph goes away from each other, just like the other day. Okay? So here, this says the absolute value of x has to be less than or equal to 8. So remember, inside here we're working with 8 and negative 8. So you have to set it up two ways again. You just take the x and you write whatever is here. X has to be less than or equal to 8. But then you also, and I'm just kind of telling you the trick to do it. I'm not really telling you why. I'm just telling you what you do. So this is x is less than or equal to 8. And then you have to do the negative number. But when you write the negative, you have to flip the direction of the inequality. That's how you set it up. So it's just a process. You write this over without the absolute value bars, then you write it with the negative without the absolute value bars, and you flip the inequality, and this is going to give you your graph, your answer. So let's see. If I graph this, I should end up with an AND graph. So I'm going to put 8. I'm going to put negative 8. This tells me I need a solid dot on 8, and everything is going this direction. This tells me I need a solid dot on negative 8, and everything goes this direction, and I do end up with an AND graph. This is an AND. Yes, this should be an AND. Less than, however you want to think about it. Okay, so this tells me that everything in between here, any number in between here, if I stick it in here, take the absolute value, it's going to be less than or equal to 8. That's what this graph tells me. All right? This is the same thing. The absolute value of r is greater than 2/3. It's an OR. I should end up with an OR graph. Greater. So I do the same thing as I did here. I set this exact same inequality without the absolute value here. And then I have to do the negative version, but when I do the negative version, I have to flip the direction of the inequality and write negative 2/3. And that's going to give me my graph, my answer. So I have negative 2/3 and I have positive 2/3 on my graph. There's no line underneath, so it's an open circle on both of these. Let's start with this one. This is saying everything is greater than 2/3, so I got to go in this direction. And this one says everything is less than 2/3, so I have to go in that direction. There we go. Okay? All right, here. This is the same thing. Just because there's stuff added inside here, it doesn't matter. You set up the same way. So you're going to have two branches off of here. You're going to take what's inside there, x plus 3, and you're going to set it greater to 8. And then over here, you do the same thing, but you flip the inequality and you set it to negative 8. And so this is where the one more step comes in. Now we have to solve for x. Okay, so we subtract 3, x is greater than 5. Subtract 3, x is less than negative 11. Before I go any further, this is a greater than 8, so I should have a what kind of graph? I should have an OR graph when I'm done. Greater. Okay? So let's graph these two numbers and see what happens. Here's a 5, here's a negative 11. No line underneath, so I have to circle 5. X is greater than 5, so it goes in this direction. Or x is less than negative 11, so it goes circle this direction, and I did end up with an OR, which is what I wanted. Okay? All right. These are all really the same thing. We're just adding a couple more steps. This one is the same as the one we just did. This is a less than, so I'm going to have an and graph when I'm done. Less than, Gorland, however you want to remember it. Greater or, less and. So I set what's ever inside here equal to the inequality as it is, or less than 11. Then I take what's inside there, flip it, and make it negative 11. And then I have to solve for s. So add 1. 2s is less than 12. Divide by 2, divide by 2. S is less than 6. So there's one of them. Then I do this one. Add 1, add 1. 2s is greater than negative 10. Divide by 2, divide by 2. S is greater than negative 5. There's my other one. Let's graph it. Hopefully we end up with an and. So I have 6, and I have negative 5. Open circle on both of them. Let's start with this one. S is less than 6, it goes in this direction. And S is greater than negative 5, goes this direction. So we got an and. What this tells me then is any number between negative 5 and 6, if I plug it in here for S, it'll make this statement true, this inequality true. All right, let's do this one here. All of this stuff is less than or equal to 13. So again, I should end up with an and. So it's the same thing. You got to take this equation apart and you got to get that absolute value thing by itself. So you start just like you would solve a regular equation. You add 8, still have the 3 out here. 21. Okay, remember, I told you yesterday, never, never, never distribute. It's tempting, but don't distribute into an absolute value. It doesn't work. So you just got to take it apart here. So you divide by 3. Again, our goal is to get this by itself. And that's 7. Now we're at the point where we can set it up, just like we were doing, and figure out what m is. So 3m minus 6, you leave that the same, set it to that. And then you do 3m minus 6, you flip it, and you make it negative 7. Okay, I'm going to add 6, 3m is less than or equal to 13. We're going to get a fraction. Doesn't matter. Did I do something wrong here? I did so. All right, I made a mistake. This is a 5, you guys, so we have to make that a 5, a 5, a 5, and a 5. I don't know where 3 came from. Sorry about that. And this is also 5. All right, to finish that one, then we have to divide by 5. Divide by 5. Oh, it's going to get tight here. I'm going to come underneath my line, and I'm going to say, okay, m is less than or equal to 13 over 5. That's okay. I can have a fraction. No problem. If you want to convert it, just so you know where to put it on the number line, 5 goes into 13 twice, and you have 3 left over, so it would look like that. All right, this one, add 6, add 6. 5m is greater than or equal to negative 1. Divide by 5. All right, so this is m is greater than or equal to negative 1/5. So I have this and I have this, however you want to look at it. So negative 1/5 would be down here. This is a tight one, I know. And this would be 2 3/5, let's say here. Solid dot on both. Let's start with m is greater than or equal to negative 1/5. That goes that direction. And m is less than or equal to 2 3/5. That goes that direction. I do have an and graph, so I did it right. Yay. Kind of messy, but we did it. Okay, this one here. I'm not going to do this one because it's the same as all these, but I want you to notice that the absolute value of 2x plus 3 minus 4 is greater than or equal to 5. That means you would end up with an or. And if you do it all just like we did these, you will end up with an or graph. So you should be good with that. Let's just talk about this last thing here. You are planning a committee for a school dance. Ticket sales for the last 10 dances are all of these. Find the mean number of tickets sold. Remember, mean is average. And it told us that we had 10 dances. So what you have to do is you have to add all of these numbers up. Use a calculator, obviously. If you add them all up, it's going to equal 1,820. And then to find the average, you divide by how many dances there were, which was 10. And that tells me that we sold an average of 182 tickets each time they sold tickets for that dance. The second part here says the dance committee estimates that they will sell the mean number of tickets with an absolute deviation of at most 40 tickets. How many of the ticket sales to the previous dances were within this range? So they're saying, okay, from 102 tickets, I could maybe sell 40 more, because that's what deviation means, 40 more than 180 on any given day, or I could sell 40 less on any given day than 180. Okay? The 182, thank you. 182. So that means that on any given day, I'm going to sell between maybe 142 and 222. So then the second part of this question says, how many of the ticket sales to the previous dances were within this range? So we got to go up to this list and we got to say, okay, how many were between 142 and 222? There's 1, there's 2, there's 3, 4, 5, 6, 7, and 8. So 8 days were between. 8 days. The ticket sales were between 142 and 222. And that is it.